Consider these 5 triangles. Each one has sides of 3 centimeter and 4 centimeter. So they differ in the size of the angles included. So the included angle is this one. And of course, it will make a difference on the measure of the third side of each triangle. So this one, the A over here, A, and A. So we wish that all of the triangles are a right triangle, so we can just apply the Pythagorean theorem, like 3 square plus with 4 square and then square root, and then we'll get that the A is equal to 5 centimeter. But in the real life, you'll find that not all the triangles are right triangles, and you have to be able to count for the third sides if you are given like a 2 sides length and the included angle. Why it's called included? But because it's in between of 2 sides. Okay, so this is what we are going to do. We are going to find the third side by derive the law of cosines and use it if we are given 2 sides and the included side, the included angle of a triangle, or what we know as SAS, side, included angle, and then side, included angle, and then side. So let's begin by consider triangle ABC, and this triangle ABC is an oblique triangles. The meaning of oblique triangle is that none of the angles of a triangle is a right angle, so don't treat it as a right angle. We cannot use the Pythagorean theorem directly over here. And let's put what we already know. So we know this is B, okay, the length is B. We also know that the length of opposite of angle C is C, and then we also know angle A. So there are 3 informations that we are given: B, C, and then angle A. Now the question is, what is the third side? This one. So to answer this, let's try to make the altitude of from point C. So if we make an altitude line, then it will be a perpendicular line, of course. So it will create 90 degree over here. So let's put it as D over here. So A to D, let's put it as X. And if this is X, okay, and the length of A to B is C, then the length from D to B will be C minus with X. So X is something that we don't know also, but we just put it as a statement. This is a variable X, okay, but C we already know. Now let's put another variable which we also doesn't know. So let's put it from C to D is H. If we put it correctly, then we can see that there are 2 triangles formed by this altitude line, ADC and CDB. I'll put it as the first triangle and second triangle. And let's separate it over here. So ADC, I'll put it over here, ADC, with this will be X, and then this will be H, and then this will be B. The hypotenuse is B. The other triangle, the second triangle, will be DBC. So I'll have DBC with the length, with the base is C minus X, and the height is H, and what we want to know is A, the hypotenuse. So let's try to understand this more. Let's first examine the first triangle. We have X, H, B, and then this is angle A. So we can write it as a cos A equal with x over B, right? The adjacent over the hypotenuse. And then sine A will be equal to h over B. So I can also write it as x equal with B times with cos A. Or for sine A, I can write it as h equal with B times with sine A. Yeah, just multiply B on both sides, and then I'll have B sine times with sine A. Same thing with the x, I'll have B times with cos A. This is what we can have from the first triangle. The second triangle, let's use, and I'll put it over here. The second triangle, we know that this is a right triangle, so that's why we can use sine and cosine over here. For the second triangle, let's use the Pythagorean Pythagorean formula. So we'll have dB square added with dc square equal with bc square, okay, or c minus x square added with h square equal with a square. Now let's put x and h by having this one. So h is b sine A, so I'll have x is b cos A square plus with the h. The h is b sine A, so added with b sine A square equal with a square. Notice we have the capital letter for A, B, C. This represent the angle, while C, B, and A, the lowercase letter, represent the length. And we have it over here. If we expand C minus B cos A square, this will be C square minus with 2BC cos A, and then plus with B square cos square A added with B sine A square, that will be equal to B square sine square A equal with A square. And let's try to examine what we can do for this one. B square cos square A plus with B square sine square A. So we can also write it as B square times with cos square A plus with sine square A equal with A square. Don't forget to put this back again. C square minus with 2BC cos A. Now this we already learned from the Pythagorean properties. Cos square A plus sine square A is equal to 1. So I'm going to rewrite again. I'll put the A square over here. So A square equal with B square times with 1. So that will be B square added with C square minus with 2BC cos A. This is what we know as the law of cosines. So it means that every time we are given only two given sides and the included angle, so it must be SAS, then we can find the length of the third side. So again, the length of the A over here is opposite of angle A, and that's how we are going to apply it on this particular problem. So let's say we have IND triangle, and we are told to find the length of I. First, let's try to examine what kind of configuration of this triangle. We have the side, we have the included angle, and then we have the side. So this is a SAS. Okay, so then we can apply the law of cosines, and let's put it again, but let's change the symbol. So we are going to find I square, okay, equal with D square plus with N square and then minus with 2 times with d times with n times with cos of I, and let's put everything in. So that will be, the d square will be 15.78 square plus with the n. The n square represent the length of the opposite of angle n, which is 8.54. 8.54 square minus with 2 times with the 15.78 times with 8.54 times with cos of, sorry, I'll put it over here, cos of 127 degree. Will it apply if it is more than 190 degree? Yes, it will. Okay, and you'll get that the I square eventually will be equal to 484.1426. Yeah, and I will be equal with 22.0032, or you can put it as 22.003 feet. Okay, that's how we can find it. But is it only apply for SAS? Can it apply for other configuration sites? Other configuration triangle? Yes, it can for SSS. So consider that we are given the triangle of LUV that has the configurations of 3 meter, 9 meter, and 7 meter. And we were told to find the angle of V. So we can tell that this is a configuration of triangle SSS. So because it has all of the sides are given, so SSS. Now if we are told to find V, then we can just write it as a V square equal with L square plus with U square minus with 2 times with L times with U times with cos of V. Okay, so let's put everything in. The V over here represent the length, so that will be 9 square equal with the L is 7 meter, opposite of angle L, plus with U square, opposite of angle U, will be 3 meter, 3 square, minus with 2 times with 7 times with 3 times with cos of V. So we'll get 81 equal with 49 plus with 9 minus with 2 times with 7 times with 3, which is 42 cos V. And then we can just write it as a cos V equal with 81 minus with 49 minus with 9 divided by negative 42. Okay, and then we'll get cos V equal with negative 0.5476, or V equal with arc cos of negative 0.5476, and we'll get that the answer will be plus minus, right? But we cannot have a negative for the angle of the triangles, so we are just going to get the positive one, and that will be 123.2038, or we can just approximate it as a 123.204 degree. And some of the triangles are not even exist, such as this one. If you have configurations of 3, 7, and 11, this cannot construct a triangle even you already have the sides, and you'll not ever find any angle on this triangle, because if you have the base is 11 and then this 3 and 7, and can you imagine this is 3 added with 7, it will be 10, but the base itself is 11, so it will never met on the other vertex. Okay, so same with this one, 10, 8, and 1. And let's say that this is a B, and C, just to bring back your memory how we can set the configurations for a triangle. So it's called a triangle inequality theorem. Inequality theorem. This is something that you already learned in 9th grade. Okay, theorem, triangle inequality theorem. It states that the sum of two sides is supposed to be greater than the third side. So A plus B supposed to be greater than C in order to make a triangle, or A plus C supposed to be greater than B, or B plus C supposed to be greater than A. If you follow this rule, then you can find a configurations of a triangle.